This is Jason with net.academy/Elliott Networks. Thanks for joining us for session 2. We're going to continue our VPC discussion on AWS networking. Quick housekeeping though, just as a reminder, it helps us if you enjoy our content to give us a thumbs up and consider a subscription. If you have questions, please put them in the comments below or email me. You can find my email on the first video in this series. That being said, let's drop right into our subject today. So we just got done discussing creating VPCs and what we have to do for that. But to make our VPC usable, one of our first steps is creating subnets. Now, if you remember from the first session, there's this kind of hierarchy of things, like subnets are contained in availability zones. Availability zones are contained within regions, right? So the subnet is an availability level zone construct, and it's a good idea to keep that in mind. So I have a CIDR block for my VPC that, because it's defined at the VPC level, that CIDR block can potentially span all availability zones or AZs within the region. A subnet spans an AZ, so it's in a single AZ, right? So that's an important thing to be aware of. The subnet is an AZ level construct. Creating it is very simple. You're just going to need to know your VPC identifier or name, and you're going to have to know your CIDR block and what IP you want associated with it. You can have as many subnets in a VPC. Well, I mean, I shouldn't say as many as you want, but you can have a lot of subnets in a VPC. You're just limited by the amount of IP space in that CIDR block to break them up. And we'll go through an example in a few minutes on what that might look like. Also, you have, if you remember, we talked about the intrinsic router. The intrinsic router is automatically attached to and becomes the default gateway for everything in the subnet object, okay? So here on this, I have two subnet objects, one that's 10.1.0.0/24, one that's 10.1.1.0/24, for example. That means if I spin up, an EC2, which is just like a VM, then in the 10.1.0.0/24, it's going to get a random IP. We'll call it 10.1.0.100. Its default gateway will be the intrinsic router. So AWS is going to reserve the first 3 IP addresses in any subnet, right? So what those are varies on the subnet that you're picking. But in our example here, that means 10.1.0.1, 2, and 3 are reserved, okay? And .1 is reserved for the gateway. Same thing over in the other subnet, 10.1.1.0/24, it's also going to reserve the top 3, okay? And there's really no way to override that behavior very easily. It's always going to act as the gateway for the subnet. There are some special cases. We may or may not get into those, but in general, your intrinsic router is going to auto-attach to each subnet. Your subnet size itself could range from a /16 to a /28. You may recognize that. That's the exact same range for our CIDR block. So you could have a single subnet in a single AZ. All right. I don't know that that would be that common. I see it in like HPC clusters and things like that, where performance is more critical than resiliency. They'll get resiliency through some other application level process. But they want everything in the same AZ. Remember, those AZs are physical buildings, right? That are geographically dispersed within a region. So you can expect anywhere from 1 to 4 milliseconds of latency between them, right? What's our recommended best practice on this one? In general, and it is a generality, not every use case falls into this, but in general, to make an application or a service more highly available, you'll usually split it into multiple AZs, okay? That means multiple subnets. Remember, a subnet is an AZ level construct. A subnet can only be tagged to a single AZ, right? Just be aware though, that's a layer 3 split. You can't span subnets across AZs. This is directly in contrast to something like GCP or Azure, where they do allow you to span a subnet object across multiple AZs. So it makes the failover maybe a little more like what we're used to in a traditional data center, right? Hopefully that makes sense. But if not, again, we have the comments. Let's get some discussion going. The next thing I want you to be aware of is when you're creating these subnet objects, there's two pieces of information you want to be aware of. One is there are availability zones and there are availability zone identifiers or IDs. The identifier is a fixed entity. AZ1 is AZ1 is AZ1, every account. AZ2 is AZ2 is AZ2, every account. The availability zone name could vary. Here you'll see I've got an example where up in Oregon, AZ2 is actually the 2A AZ. So this AZ2 is the identifier. This AZ or US West 2A is the availability zone name. The name is randomized per account. And the reason is to keep from too many resources landing in the A availability zone, or really in landing in the AZ1. If AZ1 always equaled AZ2A, for example, in Oregon's case, right? Everyone would just click this down arrow. They would pick 2A and everything would end up in the same data center. And then if I have a data center wide outage or something like that, all my resources are affected. Or I could run into scalability issues where I run out of things like ENIs or GPUs or CPUs or something like that, because everyone keeps selecting the top level AZ. So they randomize the AZ name, but the AZ identifier is fixed. This becomes important because if you prioritize performance over resiliency, you may want to go by the AZ identifier, the number, AZ1. You may say, I do want two subnets, but I want them in the same availability zone, or I have two different apps and two different accounts. You may want to make sure that they stay in the same AZ identifier if performance is more important. Because as I mentioned earlier, you can have anywhere from 1 to 4 milliseconds typically between those AZs. Remember, these could be up to 100 miles away, right? The whole point of an AZ is to provide that resiliency. If you're going to override that for performance, that's okay. Just know what you're getting into. And I mentioned or referred to this a little bit earlier. You can have a subnet can only attach to a single AZ, but an AZ could have many subnets. Okay. What does that mean? Well, it means something like this. Maybe over in AZ1, I have these 4 subnets, and in AZ2, I have these 4 subnets. They're all in the same AZ, but they're in separate, right? They're in separate subnet objects. If I want to route from 10.1.1.0/26 to 10.1.1.28/26, I do so through the intrinsic router. Note that the intrinsic router is connected to every subnet object, and it's the default gateway for every one of those, right? So every host in that first subnet over there, it can ping 10.1.1.1. Every host in this subnet over here can ping 10.1.1.65, .129, .193, respectively. Same thing in the 10.10/24 supernet, right? So keep that in mind. You might wonder, why would I do this? What's the point? Well, this is a really pretty common thing for network appliances. I want you to think a little bit about SD-WAN routers or next generation firewalls for a moment, right? I might have things like my WAN transport and my LAN side interfaces on my SD-WAN, right? Or on my firewalls, I might have something like trust, untrust, and heartbeat or management or something like that, right? Whatever, depends on the firewall vendor you have and what their recommendation is for HA. Just keep in mind, these are layer 3 boundaries, right? If I deploy an HA pair of firewalls in a data center, quite often they're in the same VLAN. There is no direct VLAN correspondence in the cloud, okay? So they're going to be in separate layer 3 domains. Now, also keep in mind, we mentioned this earlier, this is different in GCP and Azure. In AWS, it's a strict layer 3 boundary. It's a layer 2 concept, or more like a layer 2 concept, perhaps I should say, in Azure and GCP. So things like HA for a pair of next generation firewalls might look very different from a deployment model. This means it's a key step to work with your vendors for your solutions. Doesn't matter if it's Cisco or PAN or Arista or whoever. Work with those vendors and find out what their recommended architecture is and why, so that you understand it and can incorporate it into your documentation. That's it for subnets. We'll pick up session 3 before too long, and we'll take a look at route tables.
Need help? Call our cybersecurity team and book a consultation with us today.